All right, everyone, welcome back to another video here. What we're going to be doing today is actually pretty cool again. So we're going to be taking a look at processes in MATLAB. Specifically, we're going to take a look at some built-in mathematical processes in MATLAB pertaining to matrices and vectors. So we've just learned about matrices and vectors, so it's about time that we up the game a little bit and take care of math with matrices and vectors. So we're going to take a look at matrix versus element-wise math. And by the end of this video, or this unit, we'd like you to feel pretty comfortable using and describing matrix versus element-wise math. The second thing we're going to take a look at is writing our own process in the form of a function in MATLAB. And this is our first step to writing much more complicated codes. So we're starting to actually dig in and write more complicated codes at this point. So let's get going. All right, so welcome back. And what I'd like to do today is discuss the following. Let's say you had a 2x2 matrix A, shown over here, right up there. A, B, C, and D. And the A, B, C, and D here represent numbers in that matrix. What if I wanted to take A, the matrix, and multiply it by A, the matrix? So down here, what I'm going to say is I have B is going to be assigned the value of A multiplied by A. And the question is, what is going to happen when I multiply A by A, so the matrix A multiplied by the matrix A? So what I'm going to get you to do is to just pause the video for a second and see if you can calculate or predict what the value of B is going to be. All right, so just pause the video and see if you can come up with a value for B, and we'll be right back with the answer. All right, so hopefully you paused the video and gave that a try. If you did give it a try, I'm going to ask a quick question. Did your answer look like this? So the question you might ask is, how on earth did he get that answer, right? So if I take a look over here, what I've got is I've got this matrix A over here multiplied by this matrix A over here. And what it turns out to be is this answer over here, which is a little bit more complicated. So how did we actually come up with that complicated answer to A times A? So what I'm going to do is I'm just going to go through how this happens. So what we do is we take the first row of A and we multiply it by the first column of the second A matrix. So let's just walk through that. We take this first row, which has an A and a B in it, and we multiply it by this A and C. And we just don't just multiply it, we actually do what's called a dot product. So we take A over here, and we multiply it by the A to get this A multiplied by A over here. We then take B right here, and we multiply it by C down here to get B times C. And when we do this dot product, so we take this row and dot product with this column, what we get is we get A times A plus B times C. And just to highlight this, in MATLAB, that's the asterisk symbol. So that's what the asterisk symbol is doing. So how would we multiply the next component to get this one over here? So how would we get that entry there in the resultant matrix multiply? So just pause the video again and see if you can figure out how we get that entry. So let's take a look how we got that entry. So if we take this row now over here and multiply it by the next column, we're going to put the entry in the first row, second column of the matrix, which is going to be this one over here, this resultant location. So again, we do our dot product. So A multiplied by B gives us this A multiplied by B over here. And then B on this part of the matrix here, so in the first matrix we have a B multiplied by D down here, which is going to be B multiplied by D over here. So we get this dot product of AB with the column vector BD to get A times B plus B times C. If we take a look at this, we're going to get similar results for this row multiplied by this column is going to give us this result over here. And this row here multiplied by this column is going to give us this result over here. So what we can see is these row multiplied by columns is how we do a matrix multiply. And this is pretty general. So if these matrices were of different sizes, we would simply have to be careful that the number of columns in this first matrix was equal to the number of rows in this second matrix to make sure that we had all the entries in a row capable of being multiplied by all the entries in a column and then added together. So the number of columns in this first matrix has to equal the number of rows in the second matrix. The other result that you'll find is the number of rows in this matrix by the number of columns in this matrix is going to be the size of this matrix over here, the resultant matrix. So there are some rules there, and you're going to explore them in the exercises associated with matrix multiplication, but there's some rules associated with this matrix multiply. So if we take a look at trying to generalize this rule, what we're going to say is that the B matrix row entry, column entry, so if we had a row number and a column number, is going to equal to this A matrix of the whole row dot product with the A matrix of the whole column of the second A matrix there. So we can see that there is this very structured approach to the matrix multiplication. And this is what we would call matrix multiply in algebra. Now, some of you may not have seen this answer right away. So some of you may have recognized or come up with a slightly different form of the matrix multiply. And it's not wrong, all right? So just because you didn't get that first version of the matrix multiply doesn't mean that you got it wrong. The second version that some of you may have come up with is what we call element-wise multiplication or element-wise processes with matrices. And in this case, what you might find is you might take each element of the matrices being operated on, and in this case multiply this element A by this element A here to get A multiplied by A. And when we talk about an element-wise process, we put this little dot here. So we put dot multiply here to indicate that we're going to go element by element. And a nice way to remember this is that we're going point by point in the matrix. So we're going to put a point in front of the multiply operator. Or if it was to the power of, we would put a point to the power of for that particular answer. So in this case here, we're going to do point multiply, right? So A, point multiply A gives us A times A on this side here. B, point multiply B gives us B times B here in an element-wise process. C by C gives us C times C. And then lastly, D dot star D gives us D times D. So we see a very different resultant matrix here if we do an element by element multiply in MATLAB. The short form of this can be written as the B row column entry is going to equal to the A row column entry multiplied by the second matrix, in this case is also A, so A row column entry. So at this point, we've got two different versions of multiply. We've got the matrix multiply, which is the algebra version of matrix multiplication. And we've got an element by element process, which is the dot star in MATLAB, or element by element process. So at this point, I think it makes sense to go in and try this out in MATLAB. So let's go give this a try. So here I am in MATLAB, and what we're going to do is we're going to start by just simply creating an A matrix. So let's create A equals 1, 2, and then instead of 3, 4, let's get adventurous and say 4, 8, like this. All right, so there's my A matrix. And what I want to see is what happens if I do process number 1, which was matrix, matrix, multiply. All right, so that was process number 1, was a matrix, matrix, multiply. And I claimed that if I said B is equal to A times A, I was going to get a matrix, matrix, multiply. So let's take this and let's just run it. And let's call this mult. So that's going to be the name of this file. And what we see is the answer we get is 9, 18, 36, and 72. And the question is, can we verify this? So what I'm going to do down here is I'm just going to quickly write out the matrix form of this, kind of in shorthand here, so we can make quick work of just a couple of the entries of this. So this matrix was going to get multiplied by itself, which is 1, 2, and then let's go down here and still say multiplied by, this is not perfect, 4 and 8. There we go. And we're going to take the first row and dot product with the first column of the next portion here. So 1 multiplied by 1 is going to be 1. That's easy to hold in our working memory. 2 multiplied by 4 is going to be 8. And that's going to be placed here in the first 1, 1 entry of B. So 1 plus 8 is equal to 9. Let's do the second entry. So 1 multiplied by 2 is 2, plus 2 multiplied by 8 is 16. So 2 plus 16 gives us the answer 18, which is pretty neat. I could also write B equals A squared, right? So in this case here, I'm squaring the A matrix. In fact, I'm going to call this B2. I'll call this first one B1, just so we can make sure we're not seeing we're seeing the correct things. And we can see that B2 and B1 here are exactly the same answer, right? So we can see that when we square a matrix, it's the same as A matrix multiply A. The second process that we took a look at, process number 2, was element-wise multiply. And let's just take a quick look at that and call this B3 equals A. And remember, element-wise multiplication is dot star A. And B4 is equal to A dot to the power of 2. So here we're going to do an element-wise multiplication and an element-wise power to the second power. Let's just take a quick look and see what the answers are now. So if we look at element-wise multiplication, what we get is we get 1, 4, 16, and 64. Quite different than 9, 18, 36, and 72, because the operation here is element-wise and not a matrix-matrix multiply. B4 is exactly the same, which means when we take an element-wise operator like a squared, right, we actually get the square of each element or each entry independent of the other entries. So just to recap here, just a quick summary. We had a matrix-matrix multiply, which involved these dot products, right? So just quickly reviewing here, we took a row multiplied by a column to get an entry. We took another row multiplied by a column to get an entry, which gave us this idea of a row dotted with a column to get an entry of B. The element by element-wise process was simply you took an element of the A matrix, multiplied it by the element of the second A matrix, and you got the resultant entry in the B matrix. So hopefully this makes some sense for the MATLAB operations that we were using. So we're going to move forward and get a little bit deeper into this. So what we're going to do next is we're actually going to take a look at writing MATLAB functions. And this idea of MATLAB functions is something that was built into what we've already just done today. So when we did a asterisk to do matrix multiply, what we were doing was we were using a built-in process in MATLAB to take a matrix A and multiply it by itself. When we did an element by element matrix multiply, which is dot star, we took a matrix A and element by element multiplied it with another matrix A. So what I'd like to do is I'd like to create our own versions of those two symbols, and we're going to call them functions. So to write a function in MATLAB is to essentially take a process and hide the process away from the user. So the idea here is we're going to take a matrix multiply, we're going to define it within a function, and then we're going to hide that away from the user. So that all the user is going to see is the inputs here, right? So it's going to give, the user is going to give inputs to the function name, and then the outputs. So what can happen is I could write this code for you, and you would simply pick up this function code, you would put it in the directory with all your other code, and you would essentially just call this function as its own independent process. You wouldn't need to know what was actually going on inside of this function. It could be completely hidden from you, and we're going to see how that actually looks in MATLAB right now. So let's go and give this a try in MATLAB. Before we do, I'm just going to quickly reiterate, you write the word function, you have outputs, you have inputs, and then this is the process or function name. At the end of our function, we're going to use the term end to tell MATLAB that's the end of the function. Within the function is the processes or codes that we're going to hide from other users, or essentially encapsulate inside the function. So let's go and see if we can take what we just did in MATLAB and turn it into a function for people to use. So here we are. This is the actual code that we wrote. And what I would like to do is I'd like to identify quickly what was the input to this code. Well, the input for this particular code that we wrote today was simply this A matrix here. A is 1, 2, 4, and 8. And what I'm going to do is I'm going to take that away and I'm going to put that over here in my working code. I'm just going to call it the input to the function call. And I'm going to say there is my input to the function call. Over here, what I'm going to do is I'm going to do just what I told you. I'm going to say function, and then I'm going to have different outputs. So what were the outputs of my code here? I had B1, B2, B3, and B4, all as outputs to this code. So what I'm going to call this is actually the following. I call this B1, B2, B3, and B4. And I'm going to call this function, it's going to be a process, and I'm going to call it mult power. All right, so it's multiplication and powers. And the input to this function is simply the matrix A. So what you can see here is I've put a series of these processes inside of this function. And I'm going to, I'm just going to go down here to the bottom here, and I'm going to type end. So I've got 4 processes inside of this function. I'm going to tidy it up a little bit so it looks kind of nice. And what I need to do is I need to make sure I save this function as the name of the function. So I'm going to save this file as the name of the function. So it's going to be called multpower, and I'm going to hit save. I'm just going to quickly copy this process here relating the input to the outputs with the function name. And I'm going to bring that into this code over here. So I'm going to say A equals this. And then over here, I'm going to say B1, B2, B3, and B4 are all equal to the outputs of that process. Over here, I'm actually going to suppress the outputs from those processes within the function. All right, so here I'm going to hit run now. And when I hit run, it asks me for a file name. And I'm going to say this is my test of functions, like this. I hit enter. And what you can see is that now I've created outputs from test of functions that are called B1, B2, B3, and B4. More interesting would be is if I could change the names of this. So I would say this is matmult, or matmult. Whoops. This next one is going to be pow, or power. The next one is going to be element-wise mult. And the next one is going to be element-wise power. You might wonder, well, he's just changed the names from the B1, B2, B3. This is not going to work, right? Let's take a quick look and see what happens. So if I run it, you can see that I've actually created these new outputs with those same names. So what happened here was this variable A was put into this function call A here. It got put into this isolated function as A. All of these four processes were performed. It handed back each of them as B1, B2, B3, B4. And then my code picked up B1, B2, B3, B4 and assigned those outputs to these new variable names, which is pretty cool when you think about it. So this was a quick example of how we could use a function call. You might ask the question, why am I doing this? Well, if we take a look at this, a random person might come along and actually create a new matrix. And all they would need to do is simply call this function call, right? So within here, all of this gets reused by this person. And they simply have to just call the function with a new matrix. And what we could do is we could actually say, what if we just put in a random matrix over here of 5? Hit run, and what you can see is we get those 4 different kinds of matrix multiplies. So we get matrix multiply, algebra version. We get power, second power or squared matrix. We get an element-wise multiply and an element-wise power for that particular case. So this is actually pretty cool. The other thing we could do is we could actually come inside of this function here, and we could really take this one step further. And what I'm going to do now is I'm going to actually write the code for the matrix multiply for a 2x2 matrix and the element-wise multiply for a 2x2 matrix, so that you can see that this is really going to save us a lot of work if we use repeated functions in the future. So let's just call our variables A, B, C, and D the different entries of A. So A of 1, 1 is equal to A. B was equal to A first row second entry. C was equal to A second row first entry, and D was equal to A of second row second entry, like this. The matrix multiply here now becomes a little bit more complicated. So we can actually switch between our PowerPoint and our MATLAB here to figure it out. So let's go into PowerPoint. And what we see was that the matrix multiply had a first entry of A times A plus B times C. So this first entry over here would be A times A plus B times C. The next entry of that matrix is going to be, and you can check this out from your notes, A times B plus B times C. I can put a semicolon here. I would get C times A plus D times C. And the last one is going to be C times B plus D times D. So there we go. We wrote out a matrix multiply for a 2 by 2 matrix. Recall that B1 and B2 were the same thing, so I'm going to make them the same. In this case, this one was a lot easier. Element by element was A times A. The next entry was B times B. The following entry was C times C. And the last entry was D times D. And the last one here is going to be B4 equals B3. So what we can see here is this is actually quite a lot of work to do a 2 by 2 matrix multiply. I'm going to save this function, and we're going to now run this A matrix with our original 1, 2, 4, and 8, and we're going to see if we get the right answers. So here we get 1, 4, 16, 64. So that's good news. Over here we get 9, 10, 36, and 72. So we seem like we've got a little bit of an error there. So let's just take a quick look here. This is actually B times D. That second entry was off. Let's come back here and actually hit save. We'll go back into our function, hit run. So it's always important to test your functions. So in this case, we get 9 and 18, 36, and 72. So let's just check A to the second power here. And we get the same answer, 9, 18, 36, and 72. So what you can see now is if we had a series of 2 by 2 matrices, we could just simply rewrite all of this function here. Or we can create a function and forget about how a 2 by 2 matrix multiply works and an element-wise multiply works. And we can go into our code here and just reuse the mult power function every time we need it. So the power of functions here, or the power of using reusable processes called functions, is that once you've written a good function that you're going to use again and again and again, you can write that function once and then just call it as a process from the depths of MATLAB every time you need it, which is pretty awesome when you think about it. So that's the power of functions and processes. So we're going to just quickly go back to the functions PowerPoint here. Just take a quick look at it. So here, just to remind ourselves what we did in summary, was we took a look at a function. It has outputs. It can be multiple. So we saw 4 outputs in our previous example, B1, B2, B3, and B4. Fname is the function name that we used. It's the same name as the file name. And then the inputs here, we only had one input, which was A. We could use a comma to separate other inputs if we had an A and a B matrix and we try to do those matrix multiplies. There were a series of processes and codes that followed the term function. So in our case, it was calculating B1, B2, B3, and B4, the outputs, as multiply, power, element-wise multiply, and element-wise power. And then when we got to the end, we wrote the term end over here to make sure that we ended the function. So that was the way we went through it today in terms of a function. We did a little bit of programming to get a little bit more in depth. There's going to be some more examples down below in the description of this video. You'll be able to go in and actually do a little retrieval practice using those questions to see if you really are getting this and getting some good feedback on those retrieval practice questions. So we're going to end here in a second, but before we end, let's do a quick summary. All right, so let's just revisit our learning outcomes. So today we said we were going to describe math processes. We were going to do matrix multiply or matrix processes versus element-wise processes. Hopefully now you've got a good understanding of matrix processes involve linear algebra or algebra routines where you take dot products to do multiplies, whereas element-wise math takes each element and operates on another element of another matrix. We learned also about writing our own MATLAB functions to take repeatable processes or processes you're going to use over and over again and encapsulate them as functions. So these processes that once you've written it well once, you can ship it off, store it in your MATLAB library, and then recall it from the MATLAB library. It turns out that without knowing it, you've probably used quite a few MATLAB processes already. For example, the sine function, the cosine function, the multiply, the power, these are all built-in tools or functions in MATLAB that you may have used. Something like an exponential is also going to be a function in MATLAB. So there's a lot of different functions sitting inside of MATLAB that you're actually using on a day-to-day basis where you give a input to a named function and it hands back the answer, which is the output. And we're going to call that function a repeatable process. So it's a process that we use over and over and over again. So before we go, let me just remind you there's some retrieval practice questions down below. Those will also give you some feedback to make sure that you're actually really getting and understanding this material, and building that strength of understanding is really important to make coding easier. All right, so that's all for me today, and we will see you next time.